Hi guys, myself Naresh from CM Tesla College of Engineering, section Bhaskara, USA 97. Today I will discuss about introduction to functions. In the real of mathematics, function play a fundamental role acting as a building blocks, understanding relationships and patterns. A function can be visualized as a machine that takes an input process according to the specific rule and then produce the output. This rule dictates the relationship between input and output, ensuring that for each input there is an only corresponding output. Functions are obvious in mathematics, underpinning diverse fields in like calculus, algebra, analysis. And definition of function. Formally, function is a set of ordered pairs where each and input value associated with exactly one output value. This relationship can be represented using set notations or a rule that defines output in terms of input. For example, a function f of x equal to x square, input value x produces the output, and the function is typically defined by its own domain, and which specifies the right set of all possible input values. A function typically defined by its domain with specific set of possible values and range it encompasses and set of all possible output values. And domain is a function refers to a set of all permissible input values. These values are typically specified in the function determined by the context of the problem. For instance, the domain of function f of x equal to 1 by x excludes the value of x equal to 0 as division by 0 undefined. And range, the range of function encompasses the set of all possible output values which are generated by applying the function rule to the input values to the domain. For example, the range of function f of x equal to x square is all non-negative real numbers as squaring any real number in results in non-negative values. And domain and range of function. Understanding the domain and range of function is a crucial for analyzing its behavior and interpreting its results. The domain defines the set of all permissible input values, while the range of encompasses the set of all possible output values. Determining the domain and range involves examining the functions rule, identifying the restrictions and limitations on input and output values. For instance, function involving the square roots functions algorithms and may have restrictions on their domain, while the range might be limited by the function behavior, its underlying mathematical principles. And first one, domain restrictions. The domain of a function can be restricted by various factors such as avoiding division by 0, taking the square root of negative number, or ensuring that function output remains within the specific interval. These restrictions are essential for ensuring that function is well defined and that result is meaningful for the context of the problem. And second one, range of limitations. The range of function can be limited by its rule, specifies values of input or the function's overall behavior. For instance, a quadratic function have limited range, while linear function have a range that extends infinitely in both positive and negative. And for instance, quadratic function that range that extends infinitely in both positive and negative directions. And what is type of functions? The word functions is a vast and diverse, encompassing wide range of types, each with its own distinct characteristics and applications, for simple linear functions to more complex exponential and trigonometric functions. Each and mm, each type exhibits unique relationship between input and output value, resulting in variety of graphs and behavior. Understanding the different types of essential applying functions in real world scenarios, solving mathematical problems. Types and equation and graph. Linear contain equation m of mx plus c and graph is a straight line, and quadratic type contain f of x equal to x square plus bx plus c. It's a graph is a parabola and exponential contains f of x equal to a square x curve that grows rapidly. And fourth one, trigonometric function is sin x, comma, cos x or tan x. Graph is a periodic waves, and logarithmic equal to log x, log of ax that grows slowly. Understanding the graph functions. Visualizing the functions through their graphs is a powerful tool for understanding the behavior and relationship between a function. Of graph function is a visual representation of set ordered pairs that satisfy the function rule by plotting the coordinate plane, connecting them with a smooth curve, extending the curve according to the function properties. We can gain clear understanding of the function's domain, range, with key features. The graph also identify the functions, intercept, turning points, and asymptotes, which providing valuable insights to its behavior. Step 1, choose a scale. Select an appropriate scale for the x and y axis, ensuring that function key is a feature visible and easily interpretable. The scale should be consistent to and allow accurate plotting points. Step 2, calculating output values, several input values, choosing range that covers the function domain. And third one, connecting points. Connecting points, connect the plotted points for smooth curve, taking account to the function's behavior and properties. Drawing a drawing it to ensure that curve is accurate and visually appealing. And transformatic functions. Transformations of function involving altering the graph functions in various ways, such as a shifting, stretching, and compressing, reflecting. These transformations are powerful tool manipulating functions and creating new functions based on existing ones. Applying that is form Applying these transformations, we can analyze the relationship between different functions, how explaining how changes in the functions will impact behavior and graph. First one, vertical shift. Second one, horizontal shift, and third one, vertical stretch. Fourth one, horizontal stretch. And inverse of functions. Inverse of functions denoted by f of x equal to inverse the action original function f of x. In other words, if we apply the original functions f of x, the input value x, and then apply the inverse of functions, then 1x to the input value, and undoing operation, the inverse of function reverse operation performed by the original function, and swapping input and output. The relationship between functions and inverse function visualized swapping output values. If we swap output values, input and output values, the original function should be swapping the process highlights the symmetry distinction between functions. Thanks for watching video.